Okay, in this lecture, we are going to study the active and reactive power flow in power systems. So we already have the expression for active power output of a machine, synchronous machine, which is EV by XS sin del. Right, P equals EV by XS sin del. Now, in a power system, we have line reactance, a sending end voltage Vs, a receiving end voltage Vr. Let this be the line reactance XL. Let it be X itself. X. So in place of E, it will be Vs, and in place of your terminal voltage V, it will be Vr. So it will be Vs Vr divided by X sin del. This is P, and this del is the difference between del S and del R, sending end, receiving end angles. The difference between the sending and receiving end angles. Now we have current equals Vs minus Vr, sending end voltage minus receiving end voltage, divided by Jx. So here, what about I conjugate? I conjugate equals Vs conjugate minus Vr conjugate divided by, for Jx, it will become minus Jx. Right. Now, the angle between Vs and Vr, the angle between Vs and Vr is del. Okay. Now complex power S equals Vi conjugate, which is equal to Vs into, what is I conjugate? For I conjugate, we are going to substitute this. Right, we are going to substitute this Vs into Vs star minus Vr star divided by minus Jx. Let it be equation 1. Now let's assume that Vs leads Vr by angle del. Then how will you write Vr? Vr is the, let Vr be the reference voltage. So let it be angle 0 equals Vr conjugate. The angle is 0, right? So which is equal to magnitude of Vr. Let it be equation 2. Now what about Vs? Vs equals mod Vs into e raised to j del, because Vs leads Vr by angle del. So this, let it be equation 3. Okay. Now let us substitute 3 and 2 in 1, because equation 1 is complex power, right? In complex power we have Vs and Vr. The expressions for Vs and Vr are given by equations 2 and 3. So that can be substituted in equation 1. So then if you segregate the real and imaginary parts, you should get P sending and Q sending, right? P sending end and Q sending end. So how will you find it? Because here we have used Vs, right? Here in equation 1 we have used Vs. So this is basically Vs into I star, that is sending end complex power. If you take the real and imaginary part of sending end complex power, you will get active and reactive sending end powers, right? So we get PS as mod Vs into mod Vr by X sin del, which is equation 4, and let me change the color. Minute. Okay, and QS equals mod Vs squared minus mod Vs mod Vr cos del divided by X, which is equation 5. So here you can see that active power and del has a strong coupling. Then active power and voltage has a weak coupling. Then reactive power and voltage has a strong coupling, and reactive power and del has a weak coupling. Right. Now, similar to this, these equations 4 and 5, that is sending end active power and reactive power, we can find receiving end active and reactive powers also. This is sending end active and reactive powers. So now, if you want to find receiving end complex power, this SR equals PR plus JQR, which is equal to VR into I conjugate. Right. So if you find the equations similar to 4 and 5, if you write the equations similar to 4 and 5, then we will get, instead of PS, it is PR mod Vs mod Vr divided by X sin del. There is no difference in sending end active power and receiving end active power because we assume that it's a lossless line. The impedance is reactance itself. There is no resistance in the line. So this is equation 6. PR equals PS. Now what about QR? There is a reactive power drop in the line because we have considered XL for the line, or there is a reactance for the line. So QR equals mod Vs mod Vr cos del minus mod Vr squared by X. This is equation 7. Now, this is similar to, that means what we have obtained for expression, the expression for active power for a synchronous machine was EV by XS sin del. Right. This was RMS internal voltage. RMS internal voltage. This was RMS terminal voltage. Terminal voltage. Instead of this, now this is just P. Right. This is just P. Instead of this, now we obtained this one, PR, which is equal to PS. Right. So if it is a lossless machine, that means if the synchronous reactance is only there and we are not considering a resistance, then active power is also same, PE equals PT. Similar to that, here PS equals PR in power system. This is in machine. Okay, so that's all with the active and reactive power flows in power systems. We will use these concepts also in the problems which we are going to do in the next session. Thank you.